Section 7.7 covers simplifying complex fractions. If you want to know more about where complex fractions come from, we will have a video posted or have posted already to the website, a general concepts video called Rational Expressions 2, which deals with this idea of a fraction, which we say is a ratio of two different things, divided by another ratio. And I go into a pretty long explanation of what's actually going on here. So today we're going to skip all of the whys and hows, and we're going to go straight to the method of how to work with simplifying these complex expressions. All right, the general rule that I will teach to you is sort of hinted at in your book, but it's the method that they suggest that you use when simplifying these strategies is a little bit different than the method that I'm going to present. And the only case that I want to make here, or the only statement that I want to make here, is that there's more than one way to simplify these kinds of fractions. So find a way that works for you. If the method in your textbook works for you, great, continue to use it. I'll introduce a method that works for me, and if that works for you, then stick with it. Unless your instructor explicitly asks you to use a specific method, then whatever method works should be the method that you use and keep. All right? So the rule that I'm going to show you is really just the division rule for fractions, which is that if you have a fraction or a ratio on the top and a fraction on the ratio in the denominator in the bottom, then you can rewrite this as the multiplication of the reciprocal of the denominator. Now I've used a lot of fancy words there. So we call this the denominator. And of course, this is our numerator. And the word reciprocal it means essentially the inverted version of the original, or the flipped version of it. So, for example, if I had the fraction 1/3, what is the reciprocal? What is the reciprocal? I would just flip it. 3/1. And then I would simplify that to just 3. Okay? Another example, if I had 2 to the -1, well, I could rewrite this first because I have a negative exponent. This is the same thing as 1/2 to the first, or 1/2. What's the reciprocal of 1/2? Well, we flip it. It's 2/1. And that simplifies to 2. So when I use the word reciprocal, what I'm really using is a fancy math term that says take it and flip it. And that's what I've done here in the rule. So I've taken the denominator and I've flipped it. And now I should probably prove why this is true, or demonstrate why this is true. So let me take an example quickly and show you why this works. And I will use fairly easy versions of this. So what I'm saying is that if I flip this bottom and multiply, I should get the same thing as if I were to divide the top by the bottom. Well, I've picked these rational expressions that can be simplified into whole numbers for a reason. So I know that I can rewrite this as 3. Right? 3/1 is 3. And I know that I can rewrite this as 2/1, which is just 2. I know that I can rewrite this. And this is as simple as it gets. But what if I use the reciprocal rule and I keep it and I just use my method? Do I get to the same answer? So what I'm saying is that by my rule, all I've got to do is write my first term the same way that I have it, and then flip my bottom term, my denominator. And now you can kind of see how it's working. These ones are going to cancel. and I'm left with 3 over 2, which is what I got when I just simplified the top and the bottom altogether. So that's a very trivial demonstration of why this rule is true. So let's put it to use. My strategy for simplifying complex fractions is to get my numerator, no matter how complicated it is, into one fraction. So using all the skills that we've used in previous sections to combine all the terms in the top into one fraction. And then taking all the terms that are in the denominator, combining them together into one fraction, and then applying this rule. All right? So those are the steps that we're going to use. And we're going to go ahead and start in, not necessarily the deep end, but we're certainly not going to start in the kiddie pool today. So we'll pick a medium level example and demonstrate the strategy. So we have the complex expression 8x divided by x minus 4, and then we're going to divide that by 3 over x plus 4. Yes. Here I have my numerator and my denominator just the way I want it. I have one fraction here, I don't have two, and I have one fraction down here. So this is just going to be a straight application of the rule. Okay? So what I'll do is I'll keep my numerator the same way, and then I'll just flip my denominator and multiply. Okay? Now remember, when we are multiplying fractions, we multiply the top and we multiply the bottom. Okay? So that's what we're going to do here. We get the quantity 8x times x plus 4 divided by the quantity 3 over x minus 4. Now you could rewrite either one of these terms as a negative. How would that work? I could pull, like there's a positive 1 in front of this x, and there's a negative 1 in front of this 4. And I could pull that out. And you might be tempted to do this in order to try to get x plus 4 to look like x minus 4, or x minus 4 to look like x plus 4. But no matter how many times you pull something out of it, you're never going to get it to look exactly the way that you need it to make these two terms to cancel. So what the only thing left for us to do is to distribute these quantities. We have 8x squared in the top, and we have 32x. And then here we've got 3x minus 12. Yeah. That's as far as we can take it, because we don't have anything canceling in the top, in the bottom, and try as we might to rearrange these terms, we can't really get these two terms to cancel. Or can we? I should probably correct myself here, because I could write 4 plus x, or x plus 4 as 4 plus x. That's okay. And I can rewrite this term as negative 4 plus x. And if I tried to take a negative out of here, I could say that's the same thing as negative 4 minus x. And I'm still not going to get anywhere. So you see, even I can't resist the temptation to see if I can get these two terms to cancel. And here it just isn't going to work. So resisting the temptation, we get our answer the first time, and we move on. Okay? Next, we're going to use a little bit more complex of a problem. Okay. So the strategy will be to get the top, turn the top into one fraction, then turn the bottom into one fraction, apply our rule, simplify. Okay? The top, let's see. we're going to need a common denominator here, aren't we? Well, we have a squared in the first term, and we have a in the second term. The only way that we can combine these two together is if I get a common denominator. All right? Well, the common denominator here between a squared and a is going to be a squared. So I'm going to multiply the second term by a over a so that I get the same numerator in my top fraction, or the same denominator in my top fraction. So this first term will stay the same, but the second term will be a on the top and a squared in the bottom. And now, because I have a common denominator between the two terms, I can combine them, and I get b plus a over a squared. That's my top term, okay? Same approach for the bottom term. I note that my common denominator between these is going to be b squared. So I'm going to multiply my second term by b over b, and I get a over b squared plus b over b squared. And now I can combine those into one fraction, and I get a plus b over b squared. All right, so now we're in striking distance. This is the form where we can now apply our rule, where we take the denominator and flip it and multiply. So we keep our numerator, the fraction in our numerator, the same. And now I'm going to flip this term and multiply. I get b squared in the top, and I get a plus b in the bottom. Now, unlike our previous example where we couldn't really turn the terms around to get anything to cancel, in this case we can. The quantity a plus b is the same, the quantity b plus a is the same as the quantity a plus b. So these terms, in fact, cancel out, and we're left with just b squared over a squared. So that's the simplification that we can do, and it doesn't get any simpler than that. I suppose you could write it also as the quantity b over a squared, but I doubt your instructor is going to refuse this answer. All right? And just because things are better in 3, we'll do one final example, and we'll pick a fairly complex one. I showed you in our earlier example of reciprocals a situation where we had a number raised to a negative exponent, which I said that we could rewrite as 1 over that number raised to its positive version of the power. So we're going to get some problems that are going to require us to make these kinds of transformations. The example that we'll do here from the book almost finished. I know it's a lot of negative exponents here. So, looking at this example, it doesn't appear that we have a complex fraction to work with. There's really no complex fraction to simplify. Well, based on our rules of how we can rewrite negative exponents, we will find very quickly that in fact we have a whole lot of fractions on the top and a couple of fractions on the bottom. So let's start by making sure that we rewrite our numerator and denominator in terms that make sense. Okay, so what I have in the first term is 3 times 1 over x, which I could write as 3 over x. So I have 3 over x, and now I have plus x to the negative 2, we write as 1 over x squared, and y to the negative 1, we have a multiplication here, can be rewritten as 1 over y. So even though we have, initially it looks like we don't have any fractions at all, our negative exponents actually mean we have 3, and we'll combine these into 2 here in a second. And we'll probably have 2 fractions right here. The first we rewrite as 1 over y squared, and the second we rewrite x has not been raised to a negative power, so we keep it the same. We keep it on the top, but y definitely has, so we write it as the fraction. So even though our initial setup didn't look complicated or complex, it in fact is very complex. But we'll use the same strategy now that we recognize that we're dealing with a complex fraction that needs to be simplified. We'll use the method that we've been using so far, where we'll find a common denominator so that we can get our terms into one fraction, and do the same for our denominator, and then apply our rule and simplify. All right? Here I note that I can combine this fraction, the second fraction together. I get 1 over x squared y. Here I can't really do any combination yet until I apply my my lowest common denominator here. But let me start with the top. Finding my lowest common denominator here, I know that this term shares an x and an x, but I also need to, in order to get a common denominator, I need to multiply this by xy over xy in order to get a common denominator of x squared y. This just has the x in it. So when I do that, I end up with the top 3xy plus 1. And I'm going to combine now that I know that x times x is x squared and y is just y there, then my fraction on the top, my single fraction, turns into this quantity, 3xy plus 1 divided by x squared y. And then the same strategy here, I note that my common denominator is going to be y squared. So I need to multiply this term by y over y. And when I do, I get the combined fraction of 1 plus xy over y squared. Now I'm in striking distance, and I use my rule and then simplify my result. So keeping my numerator the same, 3xy plus 1 over x squared y. Now flipping the bottom and multiplying, I get y squared over 1 plus xy. And now I'm looking for things to cancel. You might be tempted to combine these things together and distribute, like distributing this term, right? Because this is multiplication, right? I have all this stuff in parentheses, actually, even though I don't write them that way. Before combining your terms together, try to see if things can simplify before you make any combination. For example, I can see with it split up that I have a y squared on the top and I have a y in the bottom. And I know that y squared over y reduces to just y. So what I'm going to do is I'm locating these places where I know I'm going to get something to cancel. And I see that I really only have one place where it does. I have just the y squared and the y. All right? Now I'm looking at this term 1 plus xy, and I note that I have xy plus 1 in my top term here, but these aren't exactly the same terms. I could switch the order of this and say it's 1 plus 3xy, but still I can't get it to cancel. So resisting the temptation to try to make it cancel, I just am left with y times the quantity 3xy plus 1 over x squared times the quantity 1 plus xy. And that's as far as it goes.